We're going to talk about electron configurations today. Electron configurations are a way that we can show where the last electron is. The arrangement of the electrons, again, is called an electron configuration. It's another way to kind of share that as we did with the quantum numbers that we did in our last video. So electrons are going to assume an arrangement so that they have the lowest possible energy. They have to follow three rules: the Aufbau principle, the Pauli exclusion principle, and Hund's rule. Aufbau just simply says that they have to occupy the lowest energy levels available first. And in multi-electron atoms, they're going to go into those sublevels where the energy is lower first and then into the higher ones. The sublevels and the way that you follow this runs just as the atomic number runs on your periodic table. So you start with hydrogen and helium, and you continue going up numerically until you get to the element that you want to land on. So in order of increasing energy level, the sequence of energy sublevels is SPDF, and that's exactly how I had you color in your quantum numbers periodic table. So again, those orbitals related to the energy, one principal energy level can overlap, and this happens with the 4s and 3d sublevels. So we're going to fill the 1s, then the 2s, then the 2p, the 3s, the 3p, we go to 4s, and then we go back to 3d. That's why we did period -1 when we got to that d sublevel when we were working with our quantum numbers. Pauli exclusion principle then talks about the electron spin and how we end up with in each orbital we have one electron spinning clockwise and one spinning counterclockwise. And on our quantum number sheet, we represented that with a plus or a minus. We're eventually going to be doing something called orbital diagrams where you represent that spin with an up and down arrow. Also, there's only 2 electrons in each single orbital. And then Hund's rule says that we have to fill each suborbital first before we can double up. So it's kind of like a car. With a car, you would put people, if you had a 3-seat car, you put one person in each seat before you would end up having somebody sit on somebody's lap. So then orbital diagrams, we'll get back to those in our next video. So let's talk real quick about electron configuration. So when you are doing electron configuration, you start with your 1s orbital. So the 1s is your n number. Then you say what orbital you're, or what block you're in, your s, p, d, or f, and then how many electrons you need. So this is the electron configuration for carbon. Now we have a periodic table we can reference. If we look at this, if we're doing the electron configuration for fluorine, for example, we're going to find fluorine on our periodic table, and fluorine is right here. And remember, our helium is over here for when we're doing this chapter. We're going to stick him over here, not over here. You always start back at 1 when you're doing these electron configurations. So your n number here would have been 1. You're in the s block here, so that's 1s, and you need both electrons because we're going to fluorine, so we got to go all the way through here. This is kind of like chutes and ladders. You got to kind of follow through numerically until you get to the element that you're working on. So we did 1 and 2. Now we're going to go 3 and 4. So this is I'm sorry. There we go. There we go. So this was 2. This is our 2. We're in the s block, and we need both electrons there. And then if we go over here, so that was 4. This is 5, 6, 7, 8, 9. This is where we're ending. Where again, our n number is 2. We're in the p block, but we only need 5 electrons. So that is the electron configuration for fluorine. The next one we're going to work on is copper, which is right here. And copper, again, we start back like our chutes and ladders. We start back at the beginning. We go 1 and 2. So we're in our 1, we're in our S block, and we need both electrons. Then we go over to lithium and beryllium. That's 2 for our N number. S block, we need both electrons. Then we go over here. Our N number is 2, and we're in the P block. We need all of those. So that's 6. Then numerically, we go down to here to sodium and magnesium. This is 3. We're in the S block, and we need both electrons. Then we go over to here. This is 3 for our N number. We are in the P block, and we need all 6 electrons. Then we go down here. This is 4. S block, we need both electrons. And then we go over to this section. Remember when we go here that our N number here is N minus 1. So if N is 4, we have to subtract 1 to get to 3. And then this is our D block, but we don't need all of the numbers here. We don't need all 10. We only need 9 to get to copper. So this is 3D9. If we go to potassium next, which is right here, is the next one that we're going to be working on. We have 1 for our, again, we start back at hydrogen and helium. 1 for our N number, S. We have both electrons that we need. Then we go to lithium and beryllium, which is 2. We are in the S block, and we need both electrons. Then we go to boron through neon. We need all of those electrons. Our N number is 2. We're in the P block, and we need all 6. If we go down here next, that is 3 for our N number. We're in the S block, and we need both electrons. Then numerically, we go over to here. This is 3 again for our N number. P block, we need 6 electrons. And then we're finally to potassium. Our N number is 4. We're in the S block. We only need 1 electron because that's our the element that we're going to. Now, there is a shortcut method that you can use, which requires you to go back to the previous noble gas in order for that to work. So if we go back to our previous noble gas, that's going to allow us to kind of do a shorthand version of this. So let me show you how to do that with some of these elements. So the first one that they're asking us to do is 10. We're going to find that on our periodic table. Our periodic table 10 is right here. And what we do is we go back numerically. We keep going back, we keep going back, we keep going back. So I'm going to go from here, I go up to here. This, remember, this whole column right here are called your noble gases. Okay, so my previous noble gas was krypton. So I'm going to put krypton in brackets. Then I go numerically. That was 36. So I'm going to go down here to 37. So 37, my N number here would be 5. I'm in the S block and I have 2 electrons. Then I go here to yttrium. This is N minus 1, so this is going to be 4. I'm in my D block. I need all 10 electrons for that. And then I'm going to continue over to here. This is N. My N number is 5. I'm in the P block, but I only need 2 electrons. So 5p2, and we're done with that. They wanted us to do cobalt next. So cobalt is here. If I back up numerically to my previous noble gas, that would have been argon. So argon is going to go in the brackets. Then after argon, I go down here. I'm in N equals 4. I'm in the S block, and I need both electrons. Then I go here. N minus 1 is 3. I'm in the D block, and I need 1, 2, 3, 4, 5, 6, 7 electrons. And then the last one that I'm going to show you how to do is bismuth. And bismuth is right, no, that's barium. Hold on, bismuth. Where's bismuth? Oh, right here. Right here's bismuth. Okay, so back the train up, back the train up, back the train up. I'm going to go down to here, keep backing my train up, and the previous noble gas would have been xenon. So I'm going to put xenon in brackets. Xenon is here, so I go down here. Here is cesium and barium. So this is 6. I'm in the S block. I need both electrons. Now, after barium, remember we go down here. And remember that this is period minus 2. So this is going to be 4F, and I need all of those. So that's 4F14. Then I come up here. I'm going to grab this. This is period minus 1. So that ends up being 5. I'm in the D block, and I need all 10 electrons. And then I'm going to go over here, 1, 2, 3 N. I'm in 6 for my N number, P block, and I need 3. And so that is your shortcut method for electron configuration.